In this video, we're going to introduce a new way of solving quadratic equations. We'll begin by taking one that looks fairly standard and using our previous methods. So in part A, we will solve the equation 2x squared plus 4x minus 5 equals 0 by factoring. As a quick review, the first thing we want to look for when we're factoring is to first see, is there a greatest common factor that can be factored out of the entire polynomial? Well, there is no common factor other than 1 for 2x squared, a 4x, and a negative 5. Once we have looked for the greatest common factor, the next step is to consider the fact that we have a trinomial, and specifically a trinomial where a is not equal to 1. Since it is a trinomial where the leading coefficient is not 1, I would choose to use the AC method. The AC method begins by first figuring out what is your AC value. So our A value here is 2, our C value is negative 5, and so we figure out that AC is equal to negative 10. And the question becomes, what multiplies to make AC and adds to make B? In this particular case, our B value is 4. So we need to figure out what multiplies to make negative 10 and adds to make 4. So we'll stop and consider what are the things that multiply to make negative 10. There is negative 1 and positive 10. There is positive 1 and negative 10. There is negative 2 and positive 5. And there is positive 2 and negative 5. There are no other integer factors of 10. Since none of these values that multiply to make 10 add up to make 4, this simply tells us that factoring is not going to work. It's not that this equation doesn't have solutions, it is simply the fact that factoring will not help us find those solutions. So in part B, we want to solve the same equation, 2x squared plus 4x minus 5 equals 0, but we want to do it using the square root property. The method for the square root property is that we always try to isolate the variable component where it's being squared. So normally I would say I would want to isolate the 2x squared term. The problem is this equation also has a 4x term. Because there's not just one variable term in this equation, and specifically because one of the variable terms is not squared, a simple application of the square root property won't work. The reality is that factoring only works for some very nice versions of these equations, and the square root property only works for different nice versions of these equations, but a significant number of equations that we will come across will not be able to be solved by factoring or using the square root property. So we'll need to rely on a more powerful method, one that might always work, but might be a little bit messier. Before we get into that, let's do a quick review. Question C, what is a quadratic equation? A quadratic equation is any equation that can be put into that form, ax squared plus bx plus c equals 0, where the a value is not equal to 0. So that is a quadratic equation. In part D, we are asked, what is the quadratic formula? Notice it is a different word. A quadratic equation is an equation you're trying to solve. The quadratic formula is a method we can use to solve any quadratic equation. So, in general, what is the quadratic formula? It is a formula that will solve any quadratic equation. Before I write down the formula, it will have a's, b's, and c's used in it, and those a's, b's, and c's are going to be a reference to the a's, the b, and the c in this quadratic equation that you're trying to solve. So the formula is stated like this. X equals the opposite of b plus or minus the square root of the quantity b squared minus 4ac, all of that over 2a. The first time you're presented with the quadratic formula, there's usually a little bit of shock. It is fairly complex looking. What we will do through the next few examples is make sure that we become comfortable working with it. A key thing to working with the quadratic formula is recognizing that you need to follow order of operations. Once we substitute in the a, b's, and c's into the formula from the equation we're solving, it is strictly an arithmetic simplification. Follow your order of operations and don't try to take too many shortcuts. So again, the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac, all over 2a. So let's move to part E, where we will use this formula to solve the same equation that we have not been able to solve using factoring or the square root property. Anytime you go to use the quadratic formula, there are two things you need to keep in mind. The first is the equation must be set equal to 0. Just like when we're factoring and we have to have the equation set equal to 0 to use the zero factor theorem, the same is true with the quadratic formula. It must be set equal to 0. The other part is you need to recognize from your equation what your a, b, and c values are going to be. So for this equation, 2x squared plus 4x minus 5 equals 0. The value of a will be 2, the value of b will be 4, and the value of c will be negative 5. It is important to connect the sign of the term with the coefficient, so c must be a negative 5 for this to work out properly. So to solve this equation, we want to remember, first off, we are solving for x. So the formula will start out x equals. So first I'm going to write it down one more time in its general form, and then I will substitute in place of the a's, the b's, and the c's the particular values. So in general, the formula is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2a. So for our particular equation that we're solving, this will become x equals the opposite of 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 5, all over 2 times 2. Hopefully you noticed when we did much of that substitution of the 2, the 4, and the negative 5, they were put in parentheses. Making sure you have parentheses when they are necessary is important, so I would suggest, especially in the beginning, more often than not, put your substituted values in parentheses. As you become more comfortable with this, you'll recognize when they are required and when you can leave them out. In terms of simplifying, order of operation indicates that we need to do anything inside a grouping symbol first. The square root itself is a grouping symbol, so our attention must first turn to what's underneath that radical. So underneath the radical, we have 4 squared minus 4 times 2 times negative 5. Of those operations, exponents must happen first. 4 squared is 16. And the second thing that needs to happen is the multiplication. Negative 4 times 2 is negative 8. Negative 8 times a negative 5 is a positive 40. So under the radical, 4 squared minus 4 times 2 times negative 5 became 16 plus 40. Since we did not look anywhere else, the negative 4 in the numerator, the plus or minus, and the all over 2 times 2 has not changed. The next piece to focus on is still underneath that radical. We still have some simplifying to do. So we have a radical, and under there we have 16 plus 40. 16 plus 40 is 56. So now that we have simplified in that grouping symbol, we can continue to simplify other areas as well. In the denominator, 2 times 2 can be simplified to 4. So our latest version of this expression is that negative 4 plus or minus the square root of 56 all over 4 is what our x values are equal to. Continuing our work, raising it back up to the right over here, we continue with x equals, and we need to continue simplifying. It is important to recognize the next thing that would have to be simplified, if any of this can simplify further, is that square root. So with the square root of 56, we need to find a perfect square factor of 56 that can be separated out into its own radical. 4 does divide into 56, and 4 times 14 is equal to 56. So we can simplify that radical to the square root of 4 times the square root of 14. So we now have x equals negative 4 plus or minus root 4 times root 14 all over 4. Continuing our simplification process, we continue with the negative 4 in the front. The square root of 4 reduces down to 2, so the radical component simplifies to 2 root 14, and we end up with negative 4 plus or minus 2 root 14 over 4. The final step of simplification that we can do here is if there is a common factor to both of the terms up in the numerator and the one term in the denominator, we can factor it out and cancel it. Well, negative 4, 2 root 14, and 4 in the denominator are all divisible by 2. So what we can do is cancel out a factor of 2 from each of those terms. So this gives us a final version of our answer as negative 2 plus or minus the square root of 14 all over 2. If this is the first use of the quadratic formula that you have ever seen, a lot of that will probably be pretty uncomfortable. The whole process will seem overwhelming at first. What you want to learn to do is to break it down into smaller pieces. The first step is just remembering what the quadratic formula is. The second step is just substituting in the a, the b, and the c values you have from your equation. Everything from there is just order of operations. What will sometimes happen, but it won't always happen, is once you have simplified under your radical component may be able to simplify. So in our case, the square root of 56 did simplify, but if that had worked out to be the square root of 58, we would have not had to do all that extra simplification we did over on the right side. And the fourth thing that can sometimes happen is once you have simplified a radical, there may be common factors floating around through the numerator and denominator, and so that's an extra step of simplification we need to get. I don't think anybody would disagree that the solution we just came up with is much more complex looking, much more messy, than any of the solutions we found when we were using factoring. The fact is, factoring works on pretty much only nice equations. If the equation gets messy at all, factoring typically doesn't work, and we end up relying on this quadratic formula. Now we do want to remember we did just solve an equation, so we want to finish off as we have before with a solution statement. Before we write our final answer, I do want to point out one other thing. In the quadratic formula, we have this plus or minus notation. What that is really telling us is that we have two solutions here. So in our particular example, we actually have one solution that is -2 plus the square root of 14 all over 2, and then the other solution is -2 minus the square root of 14, also all over 2. So plus or minus is just shorthand to say we had two possibilities. It's similar to the positive and negative answers that we get when we use the square root property. In fact, there's a direct relationship there that you'll see in the future. So technically, there are two solutions to this equation, and we can finish off with our solution set notation. The solution set is the set of numbers -2 plus root 14 all over 2 and -2 minus root 14 all over 2. There is the option to, instead of break this out into the two separate possibilities, but keep it in that condensed form, if you would prefer to write this as -2 plus or minus root 14 all over 2, and put that as your solution set, that also is a fine option.